Deep in the heart of southern Florida, beneath the endless tangle of sawgrass and cypress swamps, something has gone terribly wrong. A predator that does not belong here, one that evolved on the other side of the planet, has quietly taken over one of America's most iconic wild places. The Everglades, a river of grass stretching across nearly 4.5 million acres, an area larger than the entire state of Connecticut, is being swallowed alive. Not by drought, not by development, but by a snake. And the numbers tell a story that should stop you cold. In the most heavily infested zones, raccoon sightings have fallen by nearly 99%. Opossums have essentially vanished from areas where they were once common. An entire food web is collapsing in slow motion, and most of the country has no idea it is happening. Burmese pythons were never supposed to be here. They arrived through the exotic pet trade, escaping or being released by owners who had no idea what they were, unleashing. Today, tens of thousands of them coil through the swamps, their massive bodies threading silently through the water and brush. Nobody knows the exact number. That alone should tell you how serious this situation has become. Scientists estimate, rangers patrol, wildlife officials organize annual python hunting challenges where trained catchers comb the wetlands. And still, after everything, the needle barely moves. Since 2017, state agencies have pulled more than 10,000 pythons out of the wild. 10,000? And yet, the population keeps growing. So when officials and researchers started seriously discussing a plan that sounds like it came from a science fiction film, dropping millions of dead mice from aircraft across the Everglades, laced with a common painkiller that happens to be lethal to snakes, people had questions. Big ones. Could this actually work? And if it did, what else might it destroy in the process? That is exactly what we are going to dig into today. Stay with me, because this story goes to places you would never expect. To understand why anyone would even consider raining mice from helicopters over a national park, you first have to understand what happened on a small Pacific island roughly 8,000 miles from Florida, Guam. Before the middle of the 20th century, Guam was alive in a way that is genuinely hard to picture now. The forests were noisy with birds, dozens of species that had spent thousands of years evolving in an environment with no land predators. They nested openly, laid eggs on low branches, called out to each other without fear. Then, sometime in the 1940s, a brown tree snake arrived, most likely hidden inside military cargo. It was not a large animal, not particularly venomous to humans, but for the birds of Guam, it was catastrophic. Because these birds had no instinct to protect themselves from land predators, they were completely defenseless. The snake moved quietly through the trees at night, raiding nest after nest, consuming eggs, chicks, and adults without resistance. With no natural enemies and no competition for its prey, the population exploded. At peak density, scientists recorded up to 5,000 individual snakes per square mile of jungle. 12 bird species stopped reproducing on the island entirely. 8 species collapsed by 90%. Guam's forests fell silent, and power outages became a routine feature of island life as snakes climbed electrical infrastructure and short-circuited transformers, costing millions of dollars annually. The answer, when it finally came, was paracetamol, the same active ingredient in ordinary headache tablets. Researchers discovered that snakes cannot tolerate it due to how their bodies process certain compounds. A dose of around 80 milligrams is enough to kill an average brown tree snake. Dead mice with a pill hidden inside, attached to a small parachute, dropped from a helicopter into the forest canopy, where the snakes hunt. The mice catch in the trees. The snakes find them. The snakes die. Starting in the early 2000s, the program moved from theory into practice. Initial drops of around 2,000 bait mice produced survey results showing snake numbers in target areas had fallen by 80%. Larger operations scaled up to 30,000 mice dropped at a time. The approach was not perfect, but it was consistent, affordable, and it worked. On a small island, this was precision surgery. In Florida, it would be open-heart surgery on an ecosystem. That success is exactly why researchers began asking whether Florida was next. And the logic connecting them is surprisingly solid. Paracetamol is just as toxic to Burmese pythons as it is to brown tree snakes. That part transfers directly. But the Everglades is roughly 600 times the size of Guam, meaning any such operation would require millions of bait mice rather than thousands. And here is the part that makes it particularly relevant to Florida. Young Burmese pythons in the first years of their life are small enough that mice are a perfectly appropriate prey item. Hatchlings emerge from the egg at roughly 2 feet long and spend their early months hunting exactly the kind of small rodents that would be used as bait. There is another critical factor. Young pythons behave differently from adults. They climb. Adult Burmese pythons are largely ground animals, but juveniles move through branches and vegetation much like the brown tree snake does. A mouse hanging in the canopy from a small parachute would land directly in the hunting zone of a young python. And this is where the strategy becomes genuinely compelling. You do not need to kill every python. You need to remove the next generation before it reaches adulthood. No juveniles, no replacement for aging adults. Done consistently over years, the population would eventually hollow out from the inside. Because here is where the plan runs into serious trouble. And I want to be clear that this is not a small obstacle or a minor logistical challenge. This is a fundamental problem with the entire concept, and it comes down to one uncomfortable truth. Paracetamol does not only kill snakes. The Everglades is not Guam. Guam is an island with a deeply damaged ecosystem that had already lost most of its native wildlife before the control programs began. The Everglades, despite everything the pythons have done to it, is still one of the most biodiverse places in North America. It supports around 60 species of reptiles, more than 350 bird species, 40 mammal species, and 50 species of fish. A mouse dropped into that environment is not a targeted weapon. It is food for an enormous variety of creatures. Raccoons, which have already had their populations devastated by pythons, would find the mice. So would opossums. So would birds of prey. So would alligators. So would every opportunistic scavenger moving through the swamp. And every animal that eats a laced mouse becomes a secondary casualty of the program. The paracetamol does not distinguish between a Burmese python and a red-shouldered hawk. For the vast majority of vertebrates, it is toxic. So an operation designed to reduce the invasive python population could simultaneously poison the very species that the entire program is meant to protect. This same dilemma has surfaced in every major invasive species control effort around the world, and nowhere more divisively than in Australia. For over a century, Australia has been fighting introduced predators using a compound called Compound 1080, deployed to kill foxes and feral cats that devastate native wildlife. And in measurable terms, it works. Woylie numbers have climbed in parts of Western Australia. Wallaby populations have stabilized in treated areas. The data is real. But compound 1080 also kills eagles. It kills monitor lizards that scavenge poisoned carcasses. Birds of prey have died alongside the foxes they were meant to outlive. Some native parrots and sparrows proved sensitive enough to be killed by accidental contact with bait, and early indicators suggest that certain rabbit populations may be developing tolerance to the poison, raising the unwelcome possibility of an arms race between the chemical and the animals it targets. Australia has been weighing these trade-offs for decades. The program saves species on one side of the ledger while costing them on the other, and no one has fully resolved where the line sits. The United States encountered a parallel tension when Oxitec, a British biotech company, began releasing genetically modified mosquitoes to suppress populations of disease-carrying Aedes aegypti. Male mosquitoes carrying a self-limiting gene were released in the Cayman Islands, Brazil, and eventually Florida. They mated with wild females, the offspring did not survive, and populations fell hard. In one Brazilian city, wild mosquito numbers dropped by 95% within a year. Dengue rates in treated areas declined measurably. Then Yale researchers published findings suggesting some modified mosquitoes had left a genetic footprint in wild populations with hybrid offspring carrying fragments of the engineered genome forward. Oxitec disputed the conclusions, but the story had already reached a public prime to distrust it. In Florida, protests followed. Signs declared communities unwilling to be used as test subjects. Court challenges were filed. All of this for a program targeting a mosquito that spreads dengue and Zika. Imagine the response to millions of mice dropped from aircraft over a national park. The social dimension of wildlife management is never simple. Even when the science points clearly in one direction, public perception and institutional caution can stop a program entirely, or delay it until the damage it was designed to prevent becomes irreversible. The python situation in the Everglades has already crossed several of those thresholds. The mammal collapses are not projections, they are documented, and some of those effects may already be permanent. What makes the mouse-drop approach so compelling, despite its risks, is that the alternatives are not working fast enough. Physical removal pulls out thousands of snakes a year from a population that numbers in the tens of thousands at minimum. Trained detection dogs can locate pythons that human searchers would walk past without noticing, but even they cannot cover 4.5 million acres at a meaningful pace. Thermal drone technology helps, but it is still a tool of incremental removal, not population collapse. The Guam model matters because it is one of the only cases in modern conservation history where an invasive snake population was actually driven downward at scale. Not managed, not stabilized, reduced. And it happened not through exhaustive physical hunting, but through a delivery mechanism that covered terrain no team of hunters could reach. The lesson from that island is that targeted toxic bait, deployed from the air, can accomplish something ground-based removal simply cannot. Whether that lesson translates to an ecosystem 100 times the size, filled with non-target species competing for the same bait, is a question that research teams are still working through. The U.S. Geological Survey and the National Park Service have both been involved in python control research for years, and the paracetamol bait concept has shown encouraging results in controlled laboratory settings. But a laboratory is not the Everglades. If there is a path forward, it probably looks less like broadcasting laced mice across millions of acres and more like a precisely targeted deployment strategy. mapping the zones of highest juvenile python density, timing drops to coincide with seasons when native scavengers are least active, designing corridors that funnel bait toward python-likely locations rather than scattering it without direction. The precision required is enormous, but so is the cost of doing nothing. This is a situation with no clean answer and no easy victory. The Everglades took decades to reach this point, and recovery, if it comes, will take decades more. Every method carries a trade-off. Every solution creates a new category of risk, and the species already lost to the python invasion are not coming back. What this story ultimately forces us to ask is not just whether mice dropped from helicopters can kill pythons. The real question is what kind of mistakes we are willing to accept in the effort to fix a mistake we already made. The snakes did not walk here on their own. They were brought by human decisions and released through human neglect. The Everglades is paying for that now. If this story made you think, share it with someone who has never heard what is actually happening down there in the grass and water. And make sure you are following Terra Factor, because the next video is going somewhere you will not see coming. The snakes are not waiting, and neither can Florida.